Hello, good morning. Welcome to JCE Connect. This is Professor Srinath Ghiwari from the Department of Mechanical Engineering, Jain College of Engineering, Belgavi. So, as we have started with the joining processes from the Module 4, so in the last class we have discussed about the soldering part, and today we'll be discussing about the brazing part. So, brazing. Brazing is a method of joining two similar metals or dissimilar metals by using a filler material, which is a special fusible alloy. It produces stronger joint than the soldering. During brazing, the base metals of the two pieces which are to be joined are not melted. Whatever filler material is placed to join these two base metals is melted. The materials which are used for brazing are copper base and silver base alloys. So in brazing, we are joining two base metals using a brazing filler metal, and this brazing filler metal may be of copper base or silver base alloy, and it produces a stronger joint between the metals compared to the soldering. So now we'll discuss about the different types of brazing. So that is, first one is torch brazing. It is one of the popular types of brazing. So you have observed the torch soldering in the previous video, so it is same as that of the torch soldering. So in this, what happens is we are heating the surface by using a oxy-acetylene gas, and which is throwing a flame torch, and we are placing a filler material to it, so that whatever when it is heating the filler material, and it is filling the gap which is there, or the part which is there in the original material. So how this torch brazing is done? So before brazing, we have to clean the workpiece which has to be brazed. Then the torch brazing uses the heat of the flame from the blow torch, which is directed toward the workpiece whose surfaces are painted with the slurry of flux. Flux is used to remove the oxidation from the base metal, which does not give a oxidized metal, which will lead to the corrosion. So to avoid the oxidation, we are painting the base metal with the slurry of flux. The flame used is a carburizing type, that is oxy-acetylene flame. When the workpieces are heated to a temperature, when this workpiece is heated to a temperature greater than 450 degrees Celsius, whatever the filler material we are using is which is fed into this flame, and the filler metal melts and flows into the gap between the workpieces. Whatever gap is there between the workpieces, this filler material which is there will start melting, and the filler material melts and flows into the gap between the workpieces which you have to join. This results in a brazed joint. So the filler material used are aluminium silicon alloy, silver base alloy, and copper zinc alloys. And the flux used for reducing the oxidation and cleaning the surface is borax, boric acid, fluorides, and chlorides. So this is torch brazing, which is having the same working principle as that of the torch soldering. So the next one is furnace brazing. In this furnace brazing, whatever filler material is there, it is placed where you have to join the to base metals. Then it is allowed to flow through or to pass through a furnace. A furnace is one in which the heating takes place. And after passing through it, what happens is whatever filler metal is there, it reaches its melting point and gets melted at this point and gets joints between this metal after melting, and it starts flowing in this, and when it comes out the braze joint is done. So it is being run over a conveyor. So the filler metal is placed in between the joints where placed in between the metals to be joined. Then it is passed through the furnace where it is heated up, and which is melts at this point, and after coming out whatever is there it will be converted into a brazed joint. After heating in a furnace, what happens is this filler material melts and it flows and joins the two materials, and at the end we'll be getting a joint. So just for understanding, we'll read the sentences. So another type of brazing used is suitability in mass production. So if you want to produce in a mass, so we can continuously supply this type of joints. The semi-automated process by which metal parts are joined using a dissimilar filler material. In furnace brazing, the workpieces to be joined are cleaned, then the filler material is applied to the surface and later placed in the furnace. Next, the furnace has to be evacuated of air to eliminate any oxidation taking place. So the first we have to remove this air from this furnace so that oxidation does not take place. The whole assembly in the furnace is brought to the brazing temperature about 450 degrees Celsius. The furnace is brought to a temperature that is 450 degrees Celsius where the filler material is getting melted and flowing, not the base material. So base material should have more melting point compared to the filler material. After brazing, filler metal melts and flows into the joints, and at the end we are getting a brazed joint. So the difference between this and the torch brazing is that here the filler metal is just placed where you have to join the two surfaces, and in the furnace it is melted and it flows and joins the two surfaces. When it comes out, the brazed joint is done. Okay, so the next part is the dip brazing. The dip brazing is particularly suited for brazing aluminium. So in this, what is happening is the brazing sheet is placed over a surface to which has the joint. Then, so in this, this type of brazing is suited for aluminium brazing. So in this, first the metal is cleaned, which is to be joined. Then it is filled with the filler material near to the joints. The filler material is basically 88% aluminium and 12% silicon. And after assembling the filler metal and the metal to be joined is then passed through the air furnace for preheating purpose and to maintain the temperature to be 550 degrees Celsius. After the passing through the air furnace, it is dipped in a molten salt bath which is maintained at 590 degrees Celsius for 2 minutes. This molten salt bath serves as a heat transfer medium as well as the flux. So this heat transfer medium melts the filler metal and fills the joints between the two metal surfaces. Once the assembly is dipped in the bath, the molten flux comes in contact with all the surfaces at a time. As this bath itself is a flux, its complete bonding and oxide-free surface takes place and results in high-quality joints. So, as this molten salt bath acts as a flux and does not allow oxidation, and it also results in high-quality joints. So, at the end, we are getting a brazed joint. You can see the sheet is placed in the molten flux and it is preheated before it enters into this molten flux, and after entering, this flux will act as a heating medium and it is heated. The joint or the filler metal will be melted and it is taken out to form a brazed joint. This is called as dip brazing because it is the whatever assembly is there, it is dipped in the molten salt bath. Okay, so the next one is induction brazing. So this is the induction machine which is through which the alternate current is flowing, and this is the induction coil. So this induction coil is circular around the workpiece and the filler metal. So when the filler metals will be hit, the current flowing through this induction coil will start heating the filler metal, which will start joining the two metals or the metals to be joined, and it is filling that. So in this technique, a high frequency induction power source is utilized in order to create the heat required to braze the filler metal. So here in brazing, what we are doing is we are heating the filler metal, not the base metal. So filler metal starts melting and it solidifies when it cools and it joins the two surfaces. The two or more metals are joined together by a filler metal that has lower melting point than the base materials using induction heating. In this, we are using ferrous materials are rapidly heated from the electromagnetic field created by the alternate current in the induction coil. So it is creating a electromagnetic field which is heating the filler metal and it is melting the filler metal and joining these two metals, base metals. This is induction brazing, which is done by an induction machine. So next one is resistance brazing. So in this, what is happening is the two surfaces are brought in contact with each other, to which has to be joined together. So we are passing a current to the two surfaces. So when this metal is placed in contact with each other, the current is flowing. So this base metal acts as a resistance to the flow of current in this circuit. So this resistance create a heat. So whenever there is a resistance to the flow of current, there is a heat generated. This heat is melting the filler metal and joining the two base metals. So in this, in resistance brazing, the joint to be brazed is connected to an electric circuit. When the electric current passes through the joint, offers resistance to the passage of the electric current, which develops heat. This heat melts the brazing filler metal and joins the two workpieces. The resistance brazing is used for low volume production applications and rapid localized heating is necessary. The advantage of resistance brazing are clean operation without flames and it won't affect the surroundings and also doesn't require any skilled workforce, and it produces high quality joints. So the advantages of brazing are: it is possible to join any dissimilar metals. The bond line which is created between the two metals by the filler metal is aesthetically very neat or clean. The joint strength is strong enough for most non-heavy duty type of application. So in soldering we are not having such strong joints. It allows a bonding over a large area. We can bond the two metals for a larger area. It does not have any effect or negligible effect on the composition or the properties of a base material. It is cost effective to braze complex and multi-part assemblies. The disadvantages of brazing are: since the filler metal is used, the joint strength is less compared to the welded joint. So we are using a filler metal, and in soldering also we are using a filler metal. So this joint is less in strength compared to the welding joints. The joints may be damaged when operating at high temperatures. When these joints are operating at high temperatures, so there may be a chances of damage in these joints. It requires a closed joint, and it is done by the using of a proper fluxing agents. The flux residues which are present must be removed to avoid corrosion. It is difficult to join large sections with the brazing. If there is a large pipe or the large components, it is difficult to join with brazing. The filler materials are expensive and hence will end up to brazing process cost. So the next is the applications of brazing. So these are used in automotive to joining tubes and pipes which are there in the automotive or automobile. Used to join the wires and cables in the electrical equipments. Used in machine tools. So whatever machine tools we are using in lathe or milling machines, they are formed by using the brazing. So brazing is used to cement the carbide on the shank of the tool. We are using it in jewelry. You can see that in jewelry shops, chemical process industries, plumbing to join metal pipes and tubes by brazing, and wherever repair and maintenance works is necessary or joining is necessary, we are using brazing. So now we'll go with the differences between the soldering and brazing. So soldering is metals are joined with the help of a filler metal having low melting temperature below 450 degrees Celsius. But in brazing, the filler metal which is there, it is melting point is from 450 to 1000 degrees Celsius. In soldering, we are getting weaker joints, but in brazing, we are getting stronger joints. We can make a stronger joint in that. The solder filler metals are alloys of tin. The filler metals for brazing are aluminium, silver, copper, nickel, and gold. The flux used for reducing the oxidation is rosin. The flux used here is borax. It is an economical process. Soldering is an economical process, but brazing is not as economical as soldering. It is suitable to join metals with small thickness. The brazing is suitable to join metals with large thickness. So this is a comparison between soldering and brazing. Thank you. If you have any queries, you can contact me.